So suppose we have to sketch this polynomial. Well, the first thing I have to do is factorise it. And we're going to use the factor theorem. So let p of x equal x cubed minus 2x squared minus 5x plus 6. And let's try p of 1. That's 1 minus 2 minus 5 plus 6. Now that's 1 take 2 is negative 1, take 5 is negative 6, plus 6 gives me 0. Therefore, x minus, that was a messy therefore, wasn't it? X minus 1 is a factor of p of x. So let's divide it. X cubed minus 2x squared minus 5x plus 6 divided by x minus 1. X goes into x cubed, x squared times. X times x squared is x cubed. Negative 1 times x squared is negative x squared. Subtract. That goes away, that's what I wanted. Negative 2 plus 1 is 1x squared. No, sorry, is negative x squared. Negative 2 minus negative 1 is negative 2 plus 1, negative 1. Bring down the negative 5x. X goes into negative x squared, negative x times. X times negative x is negative x squared. That's what I wanted. Negative 1 times negative x is plus x. Subtract. Goes away. Negative 5 minus 1. Negative 6x. Bring down the 6. That looks good. X goes into negative 6x, negative 6 times. Negative 6x plus 6 gives me 0 as I wanted. Okay, that means p of x is equal to x minus 1 times x squared minus x minus 6. I've got one point where my polynomial is going to be 0 in a minute. To find the others, I have to factorise this. Now it's a quadratic, so it's probably going to be easiest to look for two numbers that multiply to give me negative 6 and add to give me negative 1. What two numbers multiply to negative 6 and add to negative 1? Well, it's going to be 3 and 2, and I want a negative in the middle, so it's going to be negative 3. So it's x minus 1, x minus 3, x plus 2. So now I have 3 points that are going to help me. So let's try sketching now. For x-intercepts, set y equal to 0. Well, if 0 equals x minus 1, x minus 3, x plus 2, then x is 1 or 3 or equals negative 2. So those are my 3 x-intercepts. For the y-intercept, make x equal to 0. Now, you can actually go back to the original. It's probably going to be easier than substituting in here. I mean, you'll get the same answer. If I put x equal to 0 in here, I'm going to get negative 1 times negative 3, which is 3, times 2 is 6. But I could have worked it out even easier up here. If x is 0, I've got 6. So if you have the unfactorised version, that may be easier. Y equals 6. And now we're ready to sketch. Okay, what do I know? My x-intercepts were 1 and 3 and negative 2, and my y-intercept was 6. And it was a positive x cubed. So that means it's coming up, going down and going up again. Can I join those up into a nice smooth curve? I don't actually know where the maximum point is, so don't worry too much about it. there's my sketch of my curve. Let's try another. Sketch y equals negative x cubed minus x squared plus 6x. Well, the first thing I have to do is factorise. And notice there's no constant term, which means I can factorise out one of the x's straight away. X. Actually, I might take the negative sign out as well. That'll just leave me with a positive x squared for a positive thing, a positive quadratic to factorise. X squared plus x minus 6. Now this bit is a quadratic, so we need two numbers that multiply to give me negative 6 and add to give me 1. What two numbers multiply to negative 6 and add to 1? Well, it's 2 and 3, and I need a positive 1 in the middle, so positive 3 and negative 2. Negative x, x take 2, x plus 3. Well, if I'm going to sketch this, let's find the intercepts. For the x-intercepts, let's let y equal to 0. 0 equals negative x, x minus 2, x plus 3. Which means x has to be 0, that's this one, or x equals 2, or x equals negative 3. So those are my three x-intercepts. And for the y-intercept, let's set x equal to 0. Well, if x is 0, this is going to be 0. So that is my y-intercept at the origin. Okay, now I know enough to sketch it. So what do I know? X-intercepts are at 0, 2 and negative 3. Get another colour. 0, 2 and negative 3. This is a negative x cubed equation. Negative x cubed. And that means it's going to be coming down, down, up and down again. Let's see if I can make a nice smooth, whoops, I was going to say a smooth curve through those points. Didn't quite go through the first one, but pretty close. And then down again. Now these actually do curve a bit more yet. It doesn't matter too much as long as you give the right idea.